student, today we are going to learn half projectile motion for 4 equations, derivation of 4 equations we are going to learn. Okay, these are the equations we are going to learn how to derive. Okay, first we will learn what is a half projectile motion. So it is x-axis, it is y-axis. So on the top of the building, just you are fired at the gun. Okay, the bullet, suppose you aimed here. Okay, it's a very long distance. Okay, definitely is going to come and hit the ground. Okay, it's going to make the projectile motion. If example, on top of the building you throw the stone at horizontal side, means definitely it's going to make us a projectile motion. Okay, so our bullet, the point is going to be changing, the direction is going to get. Okay, why this is happen? Guess why it's happened? Because of the acceleration due to gravity will be acting at the direction of y. Okay, so slowly initially you are not given any velocity in y-axis. Initial velocity of y-axis will be 0. Okay, the slowly y-axis velocity is going to be increased because of the gravitation. Okay, so now it's made as a projectile motion when you are thrown the stone from the top of the building, or you fired the gun from the top of the building. It's going to make us a projectile motion. Otherwise, the bomb is dropped from the flight or some height, that also is going to make us a projectile motion. These are the examples. Okay, from this we are going to learn 4 equations. One is a trajectory equation, another one is a time of flight, another one is a range of the object going to be travel, the final one instantaneous velocity and also angle. These are the equation we are going to learn from the projectile motion. Okay, first we will learn one by one. So I fired this side, the object is going to come here. Okay, just we have 2 resolution. One is a x side, another one is a y side. X plane. Okay, x plane, there is no gravity. Acceleration due to gravity will be 0. There is no gravity because only y direction will be acting as a gravity. Okay, in this case there is no gravity. So velocity what I given, v naught velocity I given to the bullet. Okay, it's going to be the constant. Okay, because there is no change in the velocity in x-axis. Okay, now y plane. Y plane, initially I know initially I am not given any velocity. So initial velocity of y-axis will be 0. But finally it's going to get the velocity. Okay, finally it's going to get the velocity at y-axis. Okay, we don't know what way it's going to get. Okay, because we are given only the x-axis velocity. And the gravity, acceleration due to gravity is going to be plus, because it's going to act as the downwards. Okay, the time period of x-axis and time period of y-axis will be the same. X and y, only the time is having the relation. Okay, now we are going to see what are the 4 equations we are going to derive. Okay, first is a trajectory equation. This one we are going to derive at final. Okay, the next one, maximum time of flight. Okay, so what is the maximum time will be taken to make the projectile. Then maximum range of projection. Okay, then instantaneous velocity at particular instant. Okay, velocity at particular time, any time, and also how much angle it will be make. Okay, one by one we'll do. First, time of flight. Time of flight. So I am taken y plane. Okay, we are going to derive what is the time of flight. We don't know. Okay, I am taken as a y plane, because y plane, x plane, time will be same. Initial velocity of y-axis will be 0. Okay, the gravity will be g. So I am going to take it as a equation, s is equal to ut plus of at square. It is y. I am playing only y direction. So I know already y direction initial velocity is 0. That means this fully is going to become of 0. 0 into t will be 0. So displacement of y axis, I am taken height of the object. So maximum height where you are there. Okay, it is top height of the building also you can take it. Okay, height, it's going to be the y axis of g t square. Okay, so you've got this, easily you can get the time period. Just you can do the cross multiplication. This 2 I am bringing here. 2h is equal to gt square. G also I am bringing here. So 2h divided by g is equal to t square. T is equal to just the square root 2h divided by g. The time of flight for the off projectile motion we got. The equation, second equation we got. Okay, so second equation we got. Next one, range of projection. So this is a range. I am taken range as the r. Okay, So now range of the projection, we don't know what is the range of the projection. R is equal to question mark. Okay, I am taken this side, x side will be the horizontal. Horizontal velocity is equal to horizontal displacement by time period. Okay, so time period I am taken this side, horizontal displacement is equal to horizontal velocity into time period. It's very simple. Velocity is equal to displacement by time. No, I am taken horizontal. Horizontal is going to represent as a x direction. So horizontal displacement is going to be r. This is horizontal displacement r. Horizontal velocity is going to be v naught. V naught will be constant all the point. Already I said x axis velocity will be the same because there is no affecting answer gravity. So it's going to be v naught. Time of flight, maximum time of flight. Already we have the equation for maximum time of the flight. So we derived the maximum time of flight. It's root of 2h divided by g. It's going to be root of 2h divided by g. We got what is the range of the projection also. Second equation we got. Okay. Now third one, instantaneous velocity. Velocity at particular instant, we'll take it at any point. Any point you can take it. Okay, I am taken this point. So at that particular point, see, I am taken as a C. This side velocity will be v naught. This side velocity I don't know, we'll take it final velocity, but y-axis initial velocity will be 0. Y-axis initial velocity will be 0. Initial velocity of y-axis is 0. V is equal to u plus at. Here u is 0 for initial case will be 0. V final is equal to a is going to be g gt. Okay, so we can take it, the final velocity is the g times of t. Final velocity is a g times of t. Yeah, final velocity we got at particular instant g times of t. So this side will be gt. Okay, if you know the time, you can calculate what is at velocity at the point of y-axis. Okay, this side will be v naught. The object is traveling this side. Okay, so this is a velocity of the object. Okay, so it is net velocity. Velocity at particular instant. Actually here t will come. Here t will come. Sorry, it's a mistake. It's a time period. Okay, so now I am going to calculate what is our net velocity. Just I am making as a x-axis velocity is v naught constant, y-axis velocity is a gt. Okay, so like this I am taken. I made as a small triangle. This side velocity is a constant v naught. Okay, this is object as net. It's moving as a net velocity. This side velocity is going to be gt. Okay, so this I am taken as this side is going to be g times of t. Okay, if you want velocity at resultant at the instant, particular instant, we'll get as a root of x-axis square is a v naught square plus y-axis is a gt square. Just I used as a Pythagoras theorem. Okay, so we calculated this equation also, v naught square plus g square t square. Okay, the next thing, tan theta at particular instant, what is the angle is going to make? Okay, we know opposite of this triangle and adjacent of this triangle. Okay, adjacent will be v naught, opposite will be gt. Tan alpha is equal to v naught divided by gt. We calculated what is the angle also. Alpha is equal to tan inverse of, it is opposite is gt divided by v naught. Gt divided by v naught. Okay, so tan theta opposite by adjacent, opposite is gt, adjacent is v naught, so we'll get gt divided by v naught. Okay, so velocity at this point, resultant velocity at this point, it's going to be root of gt whole square plus v naught square. We got velocity at particular instant. Okay, now finally we are going to see trajectory equation. Trajectory equation is going to represent as the off parabola, because this kind of projection is going to represent as the off parabola. Okay, so off parabola means y is equal to kx square. Just I am taken first x plane. Okay, x plane we know velocity is going to be v naught, a is equal to 0. Okay, s is equal to ut plus of at square. We know velocity is going to be constant. Okay, so it is displacement we are taken as a x. Trajectory equation you can take it x as a range as a x and height as the y. Only trajectory equation you can take it. I am taken this as x plane x, and this going to be the velocity v naught into t. This whole thing is going to be 0 because a is going to be 0. Okay, next to y plane, I am taken the same equation for y plane. Y is equal to ut, s is equal to ut plus of at square. We know s is its displacement is y axis, which is going to be called as the height, and initial velocity of y axis will be 0. Okay, initial velocity of y axis is 0. Okay, gravity is going to be g. Just we are going to substitute all in the above equation. So y is equal to 0 times plus of gt square. So y is equal to of gt square. Already we know what is a t. From this equation we can get what is a t. T is equal to x divided by v naught. Okay, so it's going to be g divided by 2 v naught square, x square divided by v naught. So y is equal to gx square divided by 2 times of v naught. So this is going to be the constant. So y is equal to kx square. If you prove this equation is going to be taken as a half projectile motion. Okay, and k is equal to k we are taken g divided by 2 v naught square. Okay, thank you for watching my video. If you like my channel, please subscribe.